All right, today we're talking about functions. Two things you need to know. If you haven't talked about this in science, you will eventually. Science uses this a lot when they're talking about experiments and research. And it's independent variables and dependent variables. What you need to know about independent variable, it's values that are chosen and they're not dependent on another variable. I'm independent. I live on my own. I pay my own bills. Right? I'm independent. I don't depend or rely on anybody else. Okay? So independent variables are ones that are chosen that don't depend on anything else. They can be at random. Okay? They're numbers you pick that don't depend or rely on anything else. Dependent variable, it depends on the input variable or the independent. Dependent relies on something else. You are dependent. You do not live on your own. You do not pay your own bills. You live with someone that pays those bills for you. Okay? They make the food. They earn the money to feed you, to give you a shelter at night. So you're dependent. So if you have any questions on whether you're independent or dependent, think about it. Independent, you're on your own. Dependent, you depend on someone else. Independent, I also call it as my input. Because it's the number that I pick, the number that I put into an equation, or what we're going to talk about is functions today. It's the number I pick and I put into the function. The dependent variable depends on the input, so I call it the output. So my independent variable is my input. I pick. It's an example I used this morning was I decide how many gallons of gas I put in my truck. Okay? Now, I can choose 1 gallon, I can choose 10, I can choose 15. All right? Now, that's my choice, right? Does that depend on anything else? No, I choose. But what depends on that is how far I go. If I put 1 gallon of gas in my truck, I'm only going to go 15 miles. But if I put 10 gallons, I'm going to go 150. All right? So your independent variable would be how many gallons of gas you put in the truck. Your dependent variable will be how far you go. All right? So if you have questions, if you can't think about it, use that example. All right? I choose how far I go based on how many gallons of gas I put into the truck. Right? My dependent variable is dependent on how many gallons of gas is in the truck. All right. Also, independent variable, you can also call it your x-coordinate, or we're also going to call it your domain. Your independent variables are your input, they're your x-coordinates, they're also the domain. Okay, domain is x-coordinates. We've talked about that before. Your output is your y-coordinates or your range. So you need to know those. So I can either say your dependent variable, I can say your output, I can say your y, I can say your range. I'm all talking about the same thing. Okay? Any questions? All right, write this down. All right, functions are a relation in which each element of the domain is paired with exactly one element of the range. You need to understand this definition of a function. Because today, a lot of your homework is just going to ask you, is this a function or not? Like the two questions below. It says, is this a function? Each element of the domain is paired with only one of the range. So each x-coordinate, your domain, remember, is your x, or your input, or your independent variable, can only be paired with one of the range. It cannot be paired with more than one number. So let's look at this first example. Your domain, 2, 4, 5, and 6 is paired with your range here. Is your domain paired with more than one element of the range? Is 2 paired with more than one number?
No.
No, it's only paired with 1. 4 is only paired with 3. 5 is only paired with 4, and 9 is only paired with 7. So is this a function?
No.
Yes. Because each element of the domain is paired with only one element of the range. Now let's look at this next one. It says 2 is paired with 1 and 3, 5 is paired with 4, and 9 is paired with 7. Is this a function? No, because 2 is paired with two numbers. Your domain, your x-coordinates, can only be paired with one number. 2 is paired with 2. So this is not a function. This is no. All right? Any questions? Easy enough. All right, write this down. All right, this table is another way they're going to represent a relation. And they're going to say, is this a function? So what you got to do is you got to look at the x-coordinates, you got to look at the domain, or the input, or the independent variable, and see if it's paired with only one of the y. So let's look. Is 4 only paired with 6? Yes. Is it paired with anywhere else? Does 4 appear twice? No. Does 7 appear twice? No, it's only paired with 10. Is 6 only paired with 11? Is 3 only paired with 8? Is 5 only paired with 4? Is 2 only paired with 9? Yes. So, is this a function? Yes. It fits the rule. Okay, now let me do this to you. Let's say instead of 9, which you don't have to write this down, just pay attention. Let's say instead of 9, they give you, let's say 6. Is this a function? Let's think about it. 4 is only paired with 6 one time, right? Is 4 paired with anything else? No. Is 7 only paired with 10? Is 6 only paired with 11? Is 3 only paired with 8? Is 5 only paired with 4? 2, is it paired with only one number? 6. Does it matter that 6, the range or y-coordinate, is paired with 2 numbers? No, it doesn't matter. Look at your rule. It says domain can only pair with one range. Does it say anything about what the range can be paired with? No. So here, 6 is paired with 2 and 4. It does not matter. Okay?
Doesn't matter.
All right, let's look at the ordered pairs they give us. 5, 1, 6, 3, 7, 5, and 5, 5. Is this a function?
No.
No. Let's figure out why. 5 is paired with 1. Is that the only thing it's paired with? No, it's also paired with 5. Because it's paired with 2 range numbers, 2 range values, this is a no. It's not a function. Because it's paired twice. It occurs twice. If I was to write this as a table, like we've done on the problem before, 5, 1, 5, 5, would it appear twice? Yes, it would. See how the x occurs twice? We can't have that. Okay? It doesn't matter that 6 is only paired with 3 and 7 is only paired with 5. 5 is paired with 2 numbers, so that cancels it out. It's not a function. All right, you need to write down the definition of a vertical line test, and then you need to draw just a small graph like this with some dots in that graph. All right, this is one thing that might help you if you're kind of lost, if you're kind of confused about what makes a function or what's not. Vertical line test sums it up, okay? And I think it's the easiest way of figuring out if it's a function or not. The rule says if the line, which is a vertical lines are up and down. If the line passes through more than one point, it is not a function. So if it has more than one point on that vertical line, it's not a function. Okay, easy enough to understand, right? So what we do here is we draw a bunch of vertical lines. Okay, right now the 3 lines I've drawn, is it a function? Yes, because there's only one point on each line. Is it still a function? Yeah. Is it a function now? No, because there's 2 points on this line. Right here and right here. So this is not a function. It fails the vertical line test. Okay? That's all we're asking for, is if it passes or fails the vertical line test. Now the reason I said it kind of sums up the definition of if it's a function or not, the way you can help is think about the problem before where it gave us 4 coordinates. Let's say those coordinates was 8, 1 and 8, negative 8, 5. and then here and here. If I wasn't for sure if it's a function or not, I could draw them, I could put them on a graph and do the vertical line test. Does it pass the vertical line test? No. So this is not a function. So the problem we did before where it was the 4 ordered pairs, you could draw them, put them on a graph, and do that. Could you do it on the table that we saw earlier? Did you put those on a graph, those coordinates? It was X and Y coordinates. Could I draw them on a graph and see if it passed the vertical line test? Yes. Could I do that on the 2 problems in the first slide? Yes. All right. So anytime you get confused on whether or not it's a function, put those ordered pairs on a graph and see if it passes the vertical line test. If it does, it's a function. If it doesn't, like this doesn't, then it's not a function. Easy enough, right? All right, you need to write this down. All right, a function that is written as an equation can also be written in a form called function notation. You have the equation here. Okay, you have the example as it in function notation. The only thing that's changed is y is now written as f of x. What this means is the function with a variable of x, which this is a function with a variable of x. Okay, that's all it means. So anytime you get confused on f of x, just replace it with y. Okay, they mean the exact same thing. They just like to write them different. All right, what you need to do is write this down and those 2 down, and we're going to answer those, and then you'll be done. All right, so what this is if f of x is equal to 4x minus 7, you're supposed to find each function value. What that means is you're supposed to figure out what y is or what f of x is, because remember, I can write this as y equals 4x minus 7. You're just figuring out what y is. Okay? What this means, f of 5 means x is 5. You're replacing x with 5. Okay? So f of 5 means I take 4, I'm timesing it by 5. I'm replacing x with 5. They replaced x with 5, so I replace x with 5, and I subtract that with 7. 4 times 5 is 20. 20 minus 7 is 13. That's my answer. So to find f of 5, I just replace x with 5 and solve. This says f of negative 6. So what I do is I replace x with negative 6. Then I subtract 7. I write it exactly how it is up here, except x is now written as negative 6. 4 times negative 6 is negative 24. Negative 24 minus 7 is negative 31. And that's my answer. Easy enough, right? Here's your assignment.